In Chapter 9, Exercise 15, they're asking you to calculate the molarity of a few different solutions. To find that, you would want to know that the molarity is the number of moles of a solute that you sprinkle in to liters of a solution. So it's a unit for concentration, how salty or sugary something is, how much solute you've sprinkled into a solution. So to find that for each of these, we're going to take this formula and try to plug those values in for each one. All right, so in the first one, they give us 0.5 moles of glucose, and then they give us 0.2 liters of the solution. So we can plug those numbers in. We have 0.5 moles of solute and 0.2 moles of solution, and so that will give us 0.5 divided by 0.2, 2.5 molar. So 2.5 molar. So molarity is the noun. When you read the unit, it's pronounced molar, and when you write it, it would just be with a capital M. So the answer for this one is that a solution that had that much solute and that much liquid, or that much solution, would be 2.5 molar. Okay. For the second one, B, they don't give us moles at first. Instead, they give us grams. But remember, you can use the molar mass to convert between grams and moles. So this is really moles in disguise. For the second thing, they give us 2 liters. So we can definitely plug that in. So we'll have 2 liters of solution. Now we just have to figure out moles, and we can plug it in on top. So they give us 73 grams of HCl. And what we want to know is how many moles of HCl that is. And to do that, you would want to look at the bottom of each box in the periodic table. So in other words, you'd want to know the molar mass. How do grams of HCl relate to moles of HCl? So the molar mass tells you how many grams are in 1 mole. And that's given to you for each element on the bottom of the box for it on the periodic table. We have 2 elements here, hydrogen and chlorine. In 1 mole of this compound, we only have 1 hydrogen, because no number is written at the bottom right of hydrogen, so it's an implied 1. If you look at the box in the periodic table, underneath the hydrogen is a 1. So each mole of hydrogen weighs 1 gram. So each mole weighs 1 gram, we only have 1 mole, so that'll be 1 gram coming from the hydrogen. In 1 mole of this whole compound, we would only have 1 mole of chlorine, because nothing is written at the bottom right, so it's an implied 1. If you look at the bottom of the box of chlorine on the periodic table, sort of in the top right, you would see that there's a 35.45 at the bottom there. So each mole of chlorine weighs 35.45 grams. Since each mole weighs 35.45 grams and we only have 1 mole, it's going to weigh 35.45 grams coming from that. So this compound altogether has that amount of hydrogen, that amount of chlorine, so add those up, and 1 mole of the whole compound would weigh 36.45 grams, so we can plug that in here. Now that we have that conversion factor, we can take the number they gave us, which is 73 grams of HCl. Every time you do a conversion, write a multiplication sign, a fraction bar, and the units you start with on top will go on the bottom of the fraction so that they cancel out. Now we're going to fill the fraction in with our conversion factor. Next to grams of HCl, we'll go 36.45. Going over the fraction bar is like going across the equal sign, so on top we'll have 1 mole of HCl. Grams of HCl cancel out. We are left with moles of HCl. And so we just want to do the math. So you do take 73 times 1, enter, divided by 36.45, enter. I'm getting around 2.003. So 2.003 moles of HCl. So we can plug that in on the top. We'll have 2.003 moles of HCl in 2 liters of solution. So now to get the molarity, we just have to plug those into the equation. So we have 2.003 divided by 2, enter, and what I'm getting for the molarity is around 1. And the way you'd read that, the way you'd write it is just with a capital M, and the way you'd read it is 1 molar. So that would be 1 molar. Okay. For C, now, again, all we needed moles of solute and liters of solution. They give us 30 grams of NaOH. Grams aren't moles, they're not liters, but they can be converted to moles, so that's really moles in disguise. And then they give us 350 milliliters of an NaOH solution, which is not liters, but again, that can be converted to liters, so that's liters in disguise. So first, getting grams to moles. We have 30 grams of NaOH, but what we want to know is how many moles of NaOH that is. Once we have that, we can plug it in to the top of this fraction in order to find the molarity. So it's a conversion question. They give us units of one thing and ask for units of another. In order to do any conversion, you need a conversion factor that relates the 2 units. So how do grams of NaOH relate to moles of NaOH? You can find the relationship between grams and moles by using the molar mass. That's the mass of 1 mole. And you find that using the periodic table. So we have 3 elements here. We have sodium, we have oxygen, and we have hydrogen. In 1 mole of NaOH, there is only 1 sodium, because no number is written at the bottom right of sodium. If you look at the boxes on the periodic table, each mole of sodium weighs 23 grams. Because we only have 1 mole, altogether it will weigh 23 times 1, that's 23 grams coming from the sodium. Oxygen. In 1 mole of this whole compound, we only have 1 oxygen, and the way you know is because nothing is written at the bottom right of oxygen. So it's an implied 1. If you look at the box on the periodic table for oxygen, there are 16 grams in each mole of oxygen. If each mole weighs 16 grams and we only have 1 mole, that'll be 16 grams total coming from oxygen. In 1 mole of NaOH, we only have 1 mole of hydrogen, and the way you know is no number is written at the bottom right of hydrogen. So it's an implied 1. Look at the bottom of the box in the periodic table. Below hydrogen is a 1, so each mole of hydrogen weighs 1 gram. If each mole weighs 1 gram, and you only have 1 mole, then you'd altogether have just 1 gram coming from the hydrogens. So NaOH is all 3 of those together. So you would add them up, 23 plus 16 plus 1, and you'd get 40. So there are 40 grams of NaOH in 1 mole of NaOH. Okay, let me make this a little smaller, set it to the side. Now that we have that conversion factor, we can do the conversion. Let's take the number they gave us, 30 grams of NaOH. Every time you do a conversion, write a multiplication sign, fraction bar, and the units you start with on top, here grams of NaOH, will go on the bottom so that they cancel out. So we'll take the side of the conversion factor that has grams of NaOH and put that at the bottom of our fraction. Going over the fraction bars like going across the equal sign, and so on top, we will have 1 mole of NaOH. Grams of NaOH cancel. We are left with moles of NaOH, which is what we wanted. And you just punch this into a calculator, so 30 times 1, enter, divided by 40, enter. I'm getting 0.75. So we'd have 0.75 moles of our solute. Okay. So that takes care of the top of our fraction for this molarity. Now we just need to convert the milliliters into liters for the bottom. So they give us 350 milliliters. We want to know how many liters that is. So it's a conversion question. We need a conversion factor that relates those two units, and you would want to remember that there are 1,000 milliliters in 1 liter. So you can take the number they give us, 350 milliliters. Every time you do a conversion, write a multiplication sign, fraction bar. The units you start with on top will go on the bottom of the fraction so that they cancel out. So we're going to take the side of the conversion factor that has milliliters and put that on the bottom. Going over the fraction bar is like going across the equal sign, and so on top we will have 1 liter. Milliliters cancel out, and we'd be left with 350 times 1, enter, divided by 1,000, enter, 0.35 liters. So we can plug that in to the molarity equation, 0.35 liters. Okay. So, the molarity is going to be 0.75 moles divided by 0.35 liters. We can plug that into a calculator. And I am getting that the molarity is 2.14. You'd write it with a capital M, and the way you'd read that is this solution is 2.14 molar. So that's how you can figure out the molarity of a solution using either the moles and liters they give you or the grams and milliliters.